Hello everybody, I had a great idea for a video. I prepared the experiment, I did some wrenching. I've carried quite a few bikes here to show you something interesting. I recorded quite a few clips and it turned out that my entire brilliant experiment went nowhere. So instead of posting a video on Monday like I hoped I'm going to, I've spent, well, the last few days on prayer. Because I hoped I'm going to get some sort of, well, enlightenment or divine intervention. I'm going to understand when I went wrong with my assumptions. However, after a few days, well, neither Sheldon nor Jobst, not even Tullio answered my prayers. It left me with nothing to post. However, I know that on the internet, if you're not posting something for a few days, well, everyone assumes you're dead, so I need to post something. I have no idea what to do. Let's adjust some brakes. So what we are going to be adjusting today are disc brakes, and obviously if you don't have disc brakes you should get them because everyone who's worth listening to has them already. I know that because I watch GCN. Adjustment of a disc brake boils down to essentially getting the brake track on the rotor between the pads without rubbing, and that is quite simple using a variety of simple methods you have probably witnessed on the internet or watched on the internet or just thought of as you are wrenching on your bike. But most of those methods presuppose implicitly that you are going to be dealing with everything in perfect working condition or even new. However, what I'm going to show you presupposes that you have something that can work. Essentially, it allows you to take into account that your rotor might be warped a bit. And what we are going to be using today are these. This is a gap gauge and we are going to be using two of those. A gap gauge is a tool that looks like a really odd Swiss Army knife. It's comprised of several blades of varying thickness. It works in a manner that you take a blade, and if you want to measure the gap in some sort of a crevice, you just stick a blade in there, and if the blade sinks in, you know that your crevice is as wide as that blade or wider. And by sticking ever wider blades in that crevice, you can measure more or less how wide the crevice really is. However, what we are going to be doing today is something a bit different, because we are going to be using varying thickness of those blades of two gap gauges to set the gaps between the pad and the rotor on your brake, and we are going to take into account that you might have different kinds of rotors or different kinds of wear on your system or different kinds of brakes. So let's start. So as you can see, this is our patient here. This is a TRP Spire on my road bike, and if you can hear, it is rubbing ever so slightly on the rotor. Now, the unique part about TRP Spires is that they have two moving pads, which is quite unusual for a mechanical disc brake. So they adjust almost like a hydraulic disc brake. However, unlike in a hydraulic disc brake, you have a control over the gap between the pads and the rotor by using the adjustment screw that's here. So I could possibly adjust this using these screws alone, but for the sake of showing you the process, I'm going to use my method. Now, this is my gap gauge number 1, this is my gap gauge number 2. They are set both to 0.4 of a millimeter, so 0.4 of a millimeter, which is quite wide for a disc brake gap, but it should allow me to adjust this brake quite easily, and then possibly adjust the pads using the adjustment screws. Now, before you're going to be sticking anything in the brake, make sure to clean those things using isopropyl alcohol, because they usually come covered in a light oil, and as you can imagine, light oil coupled to disc brake pads means you're going to be spending money on disc brake pads, which will be counterproductive. So let's loosen the caliper. Now let's back the adjustments of both pads. Okay, both are fully backed. So now the magic happens. Take a 1 gap gouge, insert between the rotor and the disc on one side, take the other gap gouge, do the same thing on the other side. You can see that they are now securely held. Theoretically, if I now tighten these screws, I should have. I'm holding the lever, by the way. If I tighten these screws, I should have the caliper perfectly centered over the rotor, and because it can't move, I can now tighten the caliper. The usual problem when tightening a caliper is that the precession here is going to cause the caliper to be misaligned, so if you're using this method you might end up with nothing in particular. However, as you can see, everything works fine, but I have massive gap. So now what I need to do is to adjust the pads. And there you go. Alright, so what's the magic here? Because obviously I just advocated for buying new stuff. There are two major methods of adjusting a disc brake. The simple one, which is the hold on to the lever, allow the caliper to cling tightly to the rotor, and then slowly tighten the screws that hold the caliper to the frame. This is the Shimano method. The other method is to visually inspect the gap between the pads and the rotor, and precisely position the caliper on the mount, so you get light between the pad and the rotor. This method is obviously much more labor intensive, but this is the method that allows you to perfectly align the caliper. Now the magic of what I just showed you allows you to connect these two methods, allows you for a very precise control over the gap between the pad and the rotor, but once you have both gap gauges between both blades of the gap gauges between the pad and the rotor, you can hold on to the lever and then easily tighten the bolts that hold the caliper to the frame. So let's discuss how to use this method on a mechanical disc brake with a fixed pad, such as this Shimano CX77. In such a caliper, the fixed pad has to be as close to the rotor as humanly possible without rubbing, and then you simply use the cable adjuster somewhere on the cable to get the moving pad as close to the pad as possible without rubbing. Now, in order to use this method, you simply add a very thin blade of the gap gouge over here. Then add another blade which is much thicker on the other side, hold to the caliper, and then hold the screws or tighten the screws. You're done. You might need to do some fidgeting in order to or some little tiny adjustment in order to avoid any rubbing, but if you're going to be tightening in this alternating fashion I showed you in the earlier clip, you should be fine. So what about hydraulic disc brakes? Assuming that you don't have some old type hydraulic disc brake with a single moving piston, such as old Maguras, such as Gustav M's, for example. The method of adjusting them is that you don't have a control over the gap between the rotor and the pad. That's something that happens automatically in the hydraulic system, which is a part of the automatic pad wear adjustment. That's an inherent property of hydraulic systems. Once you have the initial position of the pistons, you essentially take the lever, press it several times. This should reset the caliper to whatever its hydraulic system wants to be. You should then find a thickness of a blade that is the same on both sides and enters between the pad and the rotor. Then hold the lever very securely. Tighten the both bolts in the alternating fashion. You're done. Should work perfectly fine. So what to do if you have a bent rotor? Well, you do it like this. If you, first of all, we presuppose that your rotor isn't bent completely out of shape. It can go through the caliper without rubbing. You just need to find the position of the caliper that ensures that it's going to be clinging to the rotor securely without rubbing, obviously. How to achieve this lofty goal? If you have a brake with a fixed piston, such as mechanical disc brake, then choose the side which is fixed, find where the rotor is the closest to that particular side, use a very thin blade on the one gap gouge, use a thicker blade on the other side, hold to the lever, tighten both bolts in the alternating fashion, you're done. Alright, so what to do if you have a hydraulic disc brake and a warped rotor? Now pay attention, it's going to be a little bit convoluted, but I hope you're going to get the principle here. You can follow the same method as with fixed piston brake. Essentially find the maximum warp to one side, use a thin blade there, and then add a gap gouge blade to the other side to fill the space, hold, tighten the caliper. However, you can be a little bit smarter about this. If you presuppose, for example, that's an example, that your rotor is warped by 0.1 of a millimeter and the rotor is 2 millimeters thick and the space between the pads is 4 millimeters, then if you had no warp, you would use blades 0.5 of a millimeter thick on both sides. However, because your rotor is warped, then first find the maximum warp to one side and then add the value of the warp to the more spacious side of the pad and subtract it from the other. So if I had no warp, I would use blades which are 0.5 of a millimeter on both sides. However, since I have a warp by 0.1 of a millimeter, then I'm going to use 0.4 on this side and 0.6 on this side. Once I have the blades inside, hold to the lever, tighten the caliper, you should have everything perfect. Obviously you're not going to be measuring the warp of the rotor, but you can experimentally find the correct value and get, well, optimum performance out of your rotor. And that's it. I hope you found this video entertaining, or at least informative or at least entertaining. I don't really know what's more important. I hope to see you in the next video. I hope you're going to leave a like or a comment. And I am once again awkward about this shilling thing, so I think I'm going to end this video